Let's go to page 435 and start with 1. Okay, so 1a, you want to simplify, so you have 5 square root of 2. Okay, that's going to do the multiply 5 square root of 2. Okay, so when you multiply, you have to add the exponent, so this becomes 5 to the 2 square root of 2. Okay, 1b, okay, you have 5 square root of 2 to the square root of 2. So this is the exponent of exponents, so you have to apply the power rule, so you have to multiply. So this is equal to 5 square, right? This times I give you 2. And this one, when you value, you get 25. Okay. And 1c, okay, you have 5 square root of 2 plus 2 divided by 5 square root of 2 minus 2. Okay, so you have to apply the quotient rule. So this becomes 5 to the, okay, you're going to get square root of 2 plus 2 minus square root of 2 minus 2, right? So again, I do additional steps so you can see what I'm doing. Okay, so you have to kind of distribute out. So this is equal to 5 to the square root of 2 plus 2 minus square root of 2 plus 2. And so this will cancel out. So this is equal to 5 to the 4. And so this will equal to 6 to 5. Okay, next one. Okay, number 3, you got 8 to the pi square. Okay, so exponent of exponent, you apply the power rule, so you got 8 to the 2 pi, and that's it. Okay, the answer can in the different forms. Okay, depends on, but this one it doesn't ask you to make any more simplifying, so you can just leave it like that. Okay, or you can make the lowest base possible. Okay, so that's fine. Okay, number 5. Okay, you have cube root of 4 to the 6 pi. Okay, so for this one, again, the index has to go to the denominator. So this is equal to 4 to the 6 pi over 3. Right, index goes on the bottom. So this becomes 4 to the 2 pi. Okay, and that's it. Okay, number 7. Okay, you have fourth root of 9 to the 1 minus pi. Notice I put in the parentheses so that it's more clear, over 9 to the 1 plus pi. Okay, so first what you want to do is go and apply, let's go and apply the quotient rule. So you're going to get 9 to the 1 minus pi minus 1 plus pi. Okay? And so this will equal to fourth root of 9 to the 1 minus pi minus 1 minus pi. So this becomes fourth root of 9 to the 1 cancels will be minus 2 pi. Now we can take care of the roots, right? So index will go on the bottom. So this will equal to 9 to the negative 2 pi over 4. So this will equal to, I'm going to make this into 3 square. Okay, 9 make into 3 square, so I can simplify. Because on this over here, I get negative pi over 2. Okay, so now the 2 and 2 will cancel out, so this becomes 3 to the negative pi, and so this will equal to 1 over 3 to the pi. Okay, let's go to the next one. Okay, number 9, you have 2 to the square root of 2 to the negative 1 over square root of 2. So I can apply the power rule, so it becomes 2 to the negative 1, and so this is equal to 1 over 2. Okay, okay, number 11. Okay, number 11, you have square root of 2 to the pi to the 0. Well, it doesn't matter what you have, anything to the 0 power is going to equal to 1. Okay, so the answer would be 1, and that's it. Okay, number 13. Okay, you have 1 plus square root of 3 to the pi minus 1 over 1 plus square root of 3 to the pi plus 1. Okay, so apply the quotient rule. So you're going to get 1 plus square root of 3 to the pi minus 1 minus pi plus 1. Okay, so I do kind of additional steps so you can follow what I'm doing. Okay, so if you know what you're doing, you can skip this step, but you have to be extremely careful. Okay, you have to distribute the negative. So it becomes pi minus 1 minus pi minus 1. So the pi will cancel out, so you get minus 2. So this is equal to 1 plus square root of 3 negative 2. Okay, so what you need to do, you have to flip it over. So this is equal to 1 over 1 plus square root of 3 squared. But you're not allowed to have the square in the denominator, so you have to multiply out. Okay, so to square that, you square this, you get 1. The middle term, you times all this together. Okay, and the last term, you square that. So this will equal to 1 over 4 plus 2 square root of 3. Okay. Now to simplify this, you need to multiply by conjugate. So let's go and multiply by 4 minus 2 square root of 3. 4 minus 2 square root of 3. Okay, so this will equal to, so on the bottom, you're going to always do the bottom first. Okay, so you're going to get 16 minus 2 times 2 is 4. Square root of 3 times square root of 3 is 3. Okay, and on the top, you can go and multiply out. And so this will equal to 4 minus 2 square root of 3 over 4. Right? 16 minus 2 will give you 4. Now you have to divide it by 2. All these are multiple 2. So reduce every term by 2. So you're going to get 2 minus square root of 3 over 2. Okay. Okay, let's go to the next one. Okay, this one you want to solve. So you got 3 to the x equal to 1 over 27. So to solve, what you want to do is you want to try to do the matching. Okay. Okay, so over here, so you got 3 to the x equal to 1 over 3 cubed. Then you're going to flip it over. So you got 3 to the x equal to 3 to the negative 3. By matching, you got x equal to negative 3. Okay, next one, 17. You got 8 to the 2 plus x equal to 2. Okay, so that's going to make the lowest base possible. So 8 is 2 to the 3 power. And I'm going to put this as 1. So when you multiply, you get 2 to the 6 plus 3x equal to 2 to the 1. Match it up. So you got 6 plus 3x equal to 1. Okay. And so minus 6 on each side. So you got 3x equal to negative 5. Divide by 3, divide by 3. So x equal to negative 5 over 3. Okay, next one. Okay, you got 27 to the 2x minus 1 equal to 3. So let's go and make the lowest base possible. So make them the same base. So it'll be 3 cubed to the 2x minus 1 equal to 3 to the 1. Multiply out. So you got 3 to the 6x minus 3 equal to 3 to the 1. Match it up. So you got 6x minus 3 equal to 1. So plus 3 on both sides. So you got 6x equal to 4. Divide by 6. Divide by 6. So x equal to 2 over 3. Okay, let's do next one. Okay, number 21. Okay, you got 4 to the 2x plus 5 equal to 16 to the x plus 1. This one, if you notice that this is you don't want to make the lowest base possible because you can make it into base 4. Okay, so you can do that. So instead of making the lowest base possible, this is obvious you can make it into base 4. So that will save you some work on this side. So 16 is 4 squared, okay, and you can multiply out. So 4 to the 2x plus 5 equal to 4 to the 2x plus 2, okay, then you match it up. So you got 2x plus 5 equal to 2x plus 2. then minus 2x on both sides, you get 5 equal to 2. So this is impossible. So therefore, will be no solution. Okay. Okay. Next one, number 23. We're going to skip 23 because we're not going to do graphing. So let's go to 25. You have 25 to the 2x equal to 5 to the x plus 6. Okay, so this one solve each equation. Okay, so we can go and make into base 5 so we can do the matching. So 25 is 5 squared. Okay, you work it out, so you got 5 to the 4x equal to 5 to the x plus 6. Matching, so you got 4x equal to x plus 6 minus x on both sides. So you got 3x equal to 6 divided by 3 divided by 3. So x equal to 2. Okay, let's go to the next one. Let's do number 27. Okay, you have 10 to the x minus 1 equal to 100 to the 4 minus x. Okay, so this one we're going to make into base 10. Okay, again, the key is to make both sides have the same base. So 100 is 10 squared. Okay, so go and multiply out. So you got 10 to the 8 minus 2x. Match it up. So x minus 1 equal to 8 minus 2x. Now to solve, I'm going to plus 2x on this side. So this will cancel out, and I'm going to plus 1 on each side, so this will cancel out. So I get 3x equal to 9 divided by 3. So x equal to 3. Okay, next one. Number 29. Okay, you got 4 to the 2x minus 63 times 4 to the x minus 64 equal to 0. When one exponent is twice the other, that means this is the square of that. That means you want to use the quadratic form. So this is a quadratic equation. So you have to do by factoring or quadratic formula, okay, or whatever method. But first, okay, to reduce the confusion, what you want to do, you want to use something called z substitution. So what you do is let z equal to 4 to the x. Okay? And so z squared will equal to 4 to the 4x squared, right? And so this equal to 4 to the 2x. Okay, see that? So this becomes z squared minus 63 z minus 64 equal to 0. Okay? Now you can do the factoring. Okay, so negative 63, negative 64. So you're going to get 1 comma negative 64. Okay, so you're going to get z, right? So undo the first term. So you're going to get plus 1 minus 64. So from here you're going to get z equal to negative 1. And from here you're going to get z equal to 64. Once you find z, you're going to put this back. Say z equal to 4 to the x, right? So put this back in here. So you got 4 to the x equal to negative 1. 4 to the x equal to 64. Okay. Now for this one, 4 to the something is not going to give you a negative number, even if it's negative. Remember, negative exponent means you flip it over. So there's no way to get a negative number, so this one would be, there'd be no solution. For this one, okay, now notice that this is the exponent of 4, so you don't have to go all the way to base 2, okay? So this one you can just go and stay with base 4. So this would be 4 to the 3 power. But again, if it's not obvious, just go and make everything to base 2, okay? And so you can match, so x equal to 3, okay? Now again, if it's not too obvious to you, right? Then what you do is you just make it into base 2. So you're going to get 2 squared to the x equal to 2 to the 6, okay? And so you're going to get 2 to the 2x equal to 2 to the 6. Match it up, 2x equal to 6, divide by 2, divide by 2. So x equal to 3, okay? So again, if you know your base, okay, if it's obvious, you don't have to go to the lowest base. You can, as long as they are same base, then you're okay. But if it's not obvious to you, then just go and make everything the lowest base, and you should be able to get the same answer.